Okay, let's now look at an example. Suppose that temperature tomorrow is uniformly distributed between 70 and 80 degrees. Let's find the probability that the temperature tomorrow is higher than 73 degrees. I'm going to start by letting x denote the temperature tomorrow. And so let's see what we know about the variable x. We know that it is uniformly distributed between 70 and 80 degrees. Now that gives us enough information to write down the probability density function of x, so the PDF. Right? The PDF fx is going to be equal to 1 over 80 minus 70, which is 1 over 10, if x is between 70 and 80. Right? So if 70 is less than or equal to x, less than or equal to 80. And then fx is going to be 0 otherwise. So if you plot this function, you're going to get the probability density curve, right? So let's go ahead and do that. So I have my x-axis, and then I have my y-axis. And then let's say 70 is right here, 80 is going to be right about here. Then the curve between 70 and 80 is going to be a straight line, horizontal straight line, at 1 over 10. And outside of that interval, the curve is exactly the x-axis. So now we're interested in the probability, right, that the temperature tomorrow, which is x, is higher than 73. So we want the probability that x is greater than 73. Now, by definition, again, this is the area under the curve. Right? To the right of 73. Let me go ahead and split this into two probabilities. So let's have the probability that 73 is less than or equal to x, less than or equal to 80, plus the probability that x is greater than or equal to 80. In other words, in the context of of this problem in the figure here, if I have 73 being right here, then the first term is just the area of the shaded rectangle, and then the second term is the area under the curve to the right of 80. So let's look at these one by one. First, the probability that 73 is less than or equal to x, less than or equal to 80, can be computed using the formula that we derived in the previous video, right? So this is going to be equal to 80 minus 73 times 1 over 10. Which is equal to 0.7. So the first term here is 0.7. Now let's look at the probability that x is greater than or equal to 80. Now this is the area under the curve, right, to the right of 80. Okay. Which is going to be equal to the base times the height, right? Because for a uniformly distributed variable, probabilities can be expressed in terms of the area of a rectangle. I'm not going to worry about the base for now, but let's talk about the height. Notice that the curve, the probability density curve, and the x-axis are the same thing once you get past 80. Okay? So in that case, the height is basically 0. There's no height, right? Because the curve and the x-axis are the same. And so with the height being 0, regardless of what the base is, the probability in question is going to be 0. So that is 0, the second term. And so that tells us that the probability that x is greater than 73 is just going to be equal to the probability that 73 is less than or equal to x, less than or equal to 80, which is 0.7. So in this video, we looked at an example where we computed probability of a uniformly distributed variable.